everyone, welcome to week 2 of S4 Chemistry. We are continuing with our hydrocarbons topic. Just like last week's work, we will split this week into 2 sections. So the first section is alkenes. So our learning intention is that we're learning about alkenes. By the end of this section, you'll be able to state the general formula for the alkenes, name straight chain alkenes with up to 8 carbons, and write the molecular, full structural and shortened structural formula for straight chain alkenes with up to 8 carbons. So let's go straight into our next homologous series, which is alkenes. So in order to recognise an alkene, you'll see that the name ends in "ene". Now it's obviously quite similar to your alkanes, just one letter different, so you just need to make sure you're paying attention to that. They contain at least one carbon-to-carbon double bond, which we'll look at in a wee second. This tells us they are unsaturated. And this time the general formula is CnH2n. Now remember, the N tells us the number of carbon atoms in the molecule. So if you just pause here and copy this note down. So let's look at what a carbon-to-carbon double bond is. So when we looked at alkanes, between the carbon atoms there was only ever one bond. In an alkene, there has to be at least one carbon-to-carbon double bond. And what this means is that there are 2 bonds between carbon atoms. So if you look here, we've got 2 carbon atoms and there's 2 lines between them. That signifies 2 bonds. And that's what we call a carbon-to-carbon double bond. Now on to the first member of our alkenes, we're going to look at ethene. Now remember, eth means 2 carbons. Because alkenes have to have a carbon-to-carbon double bond, you cannot have an alkene with only 1 carbon. So there's no possible alkene called methene. The very first one is ethene. So let's look at our molecular formula first of all. Ethene has 2 carbons, so our molecular formula will be C2H4. Just a wee reminder of how we do that. Our general formula is CnH2n. Wherever we see an N, we replace that with 2 because there are 2 carbons, and we end up with C2H4. On to our structural formula. Remember, we always start by drawing our carbon chain first. So in this case, there are 2 carbons and we need to have a carbon-to-carbon double bond. And then we fill in our remainder hydrogens. Now remember, carbon atoms make 4 bonds, hydrogen atoms make 1 bond. And our double bond counts as 2 bonds, so each carbon has 2 more spaces. Now on to our shortened structural formula. Remember, we look at each carbon in turn. So for our first carbon, we've got CH2, our second carbon, CH2. Now you can also write this leaving in the double bond. So CH2, double bond, CH2. If you pause here and copy this down. And on to our next alkene, propene. Prop has 3 carbons, so we start with our molecular formula, and that will be C3H6. Again, just a reminder how we do this. Wherever there's an N in the general formula, we replace that with 3 because there are 3 carbons in propene, and we get C3H6. Now on to our structural formula. Remember, we always start with our carbon chain first. So propene has 3 carbons, and there needs to be 1 carbon-to-carbon double bond. So between 2 of the carbons there'll be a double bond, between the other 2 there'll just be a single bond. Then we fill in the remainder places with hydrogens, remembering that carbon makes 4 bonds and hydrogen makes 1 bond. So you just need to count and make sure that every carbon has 4 bonds around it. Okay. Then finishing with our shortened structural formula, we look at each carbon in turn. So the first one will have CH2, second CH, and the last one CH3. And remember, we can also write this by keeping the double bond in. CH2, double bond, CH, CH3. So again, if we just pause here and copy this note down. Now in a similar way to what we did with our alkanes, we're going to go through the alkenes up to 8 carbons. Okay, now in this case you've been given the name, the molecular formula and the full structural formula, and I would like you to write down the shortened structural formula. So if you just pause here and complete this table. Okay, so here is the completed table. I've showed it with both possible ways of writing the shortened structural formula. Either would be correct, whether you include the double bond or whether you don't, that's absolutely fine. Okay, now I have uploaded the PDF version of this table into the Files tab on Microsoft Teams, so if you would rather print this out rather than copy it out, that's absolutely fine. Okay, so let's think about butene now. Butene must have 4 carbon atoms because of but, and 1 double bond because it's an alkene. So we could draw it like this. We've got 4 carbon atoms and a double bond. We've got 8 hydrogen atoms. That's butene. Perfect. However, we could also draw it like this. So we still have 4 carbon atoms. We still have 1 carbon to carbon double bond. And we still have 8 hydrogen atoms. All we've ever said about alkenes is that they must have a double bond, but there's no rule to say that the double bond has to be attached to the first carbon atom in the molecule. So both of these molecules would be acceptable as butene, but they're not quite the same. And so we must be able to differentiate between the two when we name them. They cannot both just be called butene. So when we name alkenes, there are a couple of rules we need to follow. So the first rule is that we've got to look for the longest carbon chain, which includes the functional group. In this case, that's our double bond. The second thing we do is number the chain so that the double bond has the smallest possible number. And what we mean by that is you count from the end of your chain that's closest to the double bond. And the third thing we do is when writing the name of the alkene, we put the number of the double bond in the middle. Now this will make a wee bit more sense when we go through some examples. So let's look at our 2 butene examples from earlier. So looking at the first one, that is our longest carbon chain. We can see that there are 4 carbons in a row. Now we want to number each of these carbons closest to the double bond end first. And in that case, we get 1, 2, 3, 4. Now we can see that our double bond starts on carbon number 1. And so instead of just calling this butene, we would call it but1ene. Now let's look at our other molecule of butene. Again, we've got 4 carbons in a row, that's our longest carbon chain. And if we number our carbons, now in this case you could have numbered from either end, it doesn't matter, okay, because the carbon to carbon double bond is just as close to either end. But we can see that the double bond starts on carbon number 2. And so instead of just calling this butene, we would call it but2ene. So if you pause here and copy this down. So let's look at another example together. So the first step we do is to identify the longest chain. And so we can see here that our longest carbon chain is 6 carbons in a row. Then the next step is to number our carbons starting at the end closest to the double bond. So in this example, we wouldn't start from the left-hand side, we would start from the right-hand side. So that our carbon to carbon double bond starts this time on carbon number 2. So we have 6 carbons, that's got a prefix of hex. Our carbon to carbon double bond starts on carbon number 2, and so our alkene would be called hex2ene. So a big reminder that you must always count from the end closest to the double bond. And again, if we just pause here and copy this example down. Now there are a couple practice questions for you here. I would like you to pause, try the questions. We're going to name the below alkenes, and the answers will be coming up on the next slide. Okay, here are our answers. So number 1 is pentane. We've got 5 carbons in a row, and the double bond starts on carbon 2. Number 2 would be oct-14. There's 8 carbons in a row, and the double bond starts on carbon number 4. And then the third one, we've got butanene. There are 4 carbons, and numbering from the end closest to the double bond, we would have the double bond starting on carbon number 1. Let's have a quick think about ethene and propene, because when we first covered them, we didn't think of any way about numbering. So why do we not need to number the carbon chains when we name ethene and propene? So if we think about these alkenes, the carbon-to-carbon double bond always has to start on the first carbon. And so because of this, we don't have to worry about numbering. So let me just show you an example with propene. So there are 2 possible ways of drawing propene. You can either have the double bond starting at the carbon closest to the left, or the double bond starting at the carbon closest to the right. Now if we number both of these chains, looking at the first one, you always number closest to the double bond, so that would be 1, 2, 3, starting at the left. Or if we look at the one on the right hand side, remember you always number starting closest to the double bond, we would number it 1, 2, 3, starting at the right hand side. But if you look here, both of these would then be named prop-1ene. So instead of calling them prop-1ene, you can just call them propene. And the same applies to ethene. So you never have to worry about numbering ethene or propene. So that's part 1 done, alkenes complete. So just there we were learning about alkenes. We should now all be able to state the general formula for alkenes. We should be able to name straight chain alkenes with up to 8 carbons. And we should be able to write the molecular, full structural and shortened structural formula for straight chain alkenes with up to 8 carbons. Okay, on to part 2 of this week's lessons. We're looking at cycloalkanes. So for the success criteria, we will be able to state the general formula for cycloalkanes, name cycloalkanes with up to 8 carbons, and write the molecular, full structural and shortened structural formula for cycloalkanes with up to 8 carbons by the end of this section. So for cycloalkanes, their names all start with cyclo and end with ane, so that's how we can identify them from their name. They're arranged in a ring structure, so the name cycloalkane gives that away, as cyclo makes us think of a cycle. They contain single carbon-to-carbon bonds, so they are saturated, and the general formula for them is CnH2n. Now remember, N is our number of carbon atoms in the molecule. If you pause here and copy this down. So starting with our first member of the cycloalkanes, we have cyclopropane. Now prop equals 3 carbons. You cannot possibly have a cycle or ring structure with 1 or 2 carbons, so you'll never see cyclomethane or cycloethane, they don't exist. The very first member of our cycloalkanes is cyclopropane. So if we start with our molecular formula, it is C3H6. So as always, just a reminder how we do this, we look at our general formula, CnH2n, and we substitute in N equals 3, as there are 3 carbons in the molecule. and we end up with molecular formula of C3H6. Next up is our full structural formula. We always start with our carbons first. Now we're going to have 3 carbon atoms arranged in a ring. That means they should all be connected in a cycle together. So if we do this, we would end up with 3 carbon atoms connected, and the easiest way to draw that is in a triangle. Now you'll see that every carbon atom currently has 2 bonds attached to it, and carbon atoms can make up to 4 bonds, so we fill the remainder places with hydrogens to get our full structural formula. Now for our shortened structural formula, in this case, usually we collapse all the bonds and look at every carbon in turn, but we need to keep the carbon to carbon bonds to show the structure is in a ring. So instead this time we collapse our carbon hydrogen bonds in to write CH2, but we keep the carbon to carbon bonds to show that they're attached in a ring. If we pause here and copy this down. On to our next member of the cycloalkanes, we have cyclobutane. But tells us there are 4 carbons. So starting with our molecular formula, we'll have C4H8. And again, just a wee reminder of how we do this, replacing N as 4 because there are 4 carbons in the molecule. Now looking at our full structural formula, we start with our carbons first, and we have 4 carbons in a ring. Again, every carbon currently has 2 bonds attached to it, so we can add on an additional 2 hydrogens to every carbon to complete the full structural formula for cyclobutane. And then looking at our shortened structural formula, again remember we leave the carbon-carbon bonds as they are, but we collapse our carbon-hydrogen bonds. We would end up with a shortened structural formula like this. So again, if we just pause here and copy this down. Now, as we have done with the alkanes and the alkenes, we want to be able to name, write the molecular formula, write the full structural formula, and write the shortened structural formula for up to 8 carbons. So in this case, you've been given the full structural and the shortened structural for each, and I would like you to write the name and the molecular formula. So if you pause here and complete this in your notes. So here is our completed table. At the top we had cyclopentane, C5H10, then we had cyclohexane, C6H12, cycloheptane, C7H14, and then cyclooctane, C8H16. Now, as before, this handout has been uploaded into the Microsoft Teams files section if you would prefer to print this out rather than copying it out. Okay, just go up there and you can find it. So that's part 2 now complete for cycloalkanes. We were learning about cycloalkanes, and we should now all be able to state the general formula for cycloalkanes, name cycloalkanes with up to 8 carbons, write the molecular, full structural and shortened structural formula for cycloalkanes with up to 8 carbons. So last up, we've got exercise 2 for this week. So these questions cover alkenes and cycloalkanes. There are 9 questions and it's out of 20. So I would like you to pause here and complete these questions and then submit your answers to me for marking. Now remember, there are 3 ways that you can submit. The preferred option is to admit it in your submissions for your assignment on Microsoft Teams. There should be a wee bit where you can attach your work when you click hand in, and that means it's just easy for you to go back and find it, and I can give you feedback and your mark on there and it's all recorded. But if you're struggling with that, you can email it across to me, that's also no problem. Or you can complete the work in your class notebook on Microsoft Teams if you're using that instead of a jotter. Any of the 3 methods is fine. Now, because you have to draw some full structural formula, ideally if you could do this by hand on pen and paper and take a photo of those as part of your submission, that would be great. just because you need to get practice with that, as that's what you would be expected to do in an exam or test. But if you're struggling with that or you can't quite manage it, don't worry if you want to do it on the computer. Again, if you've got any questions, if you're struggling with anything, you're unsure, just give me an email. I'm always there to help, okay? Good luck!